Hi, and welcome to Algebra Lesson 1-5. We're going to talk today about adding and subtracting real numbers. We've been working on this similar stuff now for about a week. We have a little bit more of this, so we're going to go ahead and get started with adding and subtracting real numbers. So let's go ahead and get started with our anticipatory set. Now, one of my favorite things to do when I'm bored is to watch American Ninja Warrior. It is so much fun. So what we're going to do today is, at least for our anticipatory set, we're going to talk just a bit about one of my favorite things to watch while I'm watching American Ninja Warrior. And what that is, I think the obstacle is called the spider jump. Actually, jumping spider, I believe, is what it's called. If you've ever seen American Ninja Warrior, you know what I'm talking about here. Now, the way it works is that there is this crazy looking obstacle. And this obstacle is it's off the ground a little bit, and it looks a little something like this. I'm trying to make it straight, but what it does is it's these two walls, and these two walls are right next to each other. Just wide enough for you to pin your body in between. And when you jump up onto the jumping spider, you have to pin your body like that, and you have to stay there, and you have to walk all the way across until you get to the end where you have to jump completely off of the thing, and there is a landing pad about right here. That's sort of what it looks like. So this is a wall. On the other side of this, there's a wall too. And what the people do, and it's very, very impressive, is they jump. They run and they jump like that. They're going very fast. And they jump up and they pin themselves in there. So from here, they have to jump up like 9 feet. And then they have to like crawl their way along here. They have to drop down, it's about 3 feet. And they have to move their way this way, and then they have to go up all this distance. They have to lift themselves up to the top of this here, which is like 11 feet, and then they have to go all the way over, drop down into this little landing or this dismount area, and then they have to jump like 10 feet down to this pad, and then they go on to the next obstacle. And it's insane. It's very crazy, and it's like my favorite thing to watch ever. So let's go ahead and get started. We'll come back to this in just a bit. So let's first of all take a look at our standard. Our standard is going to be one that we've been covering already, and the standard is N-RN. Got that wrong already. N-RN.B.3. So that's our standard. That's what we're tagging our standard as. And we're going to go ahead and write down. Now, we're not going to write the entire thing. I know I've written this standard before. At least you should have written this standard before. So what we're going to go ahead and write is just sort of the important part that we're going to need to know about today. So let's take a look. And it says, explain why the sum or product of two rational numbers is rational, and that the sum of a rational number and an irrational number is irrational. And that's not the end of the standard, but that's all we're going to be writing down. Okay, so make sure that is down where you're taking notes as well. And in case you're wondering, up here, this is the real number system. Real number system is what this standard is, or standard B3 when it comes to that. Okay, so now that we are ready to go, let's get right into our input. We have a few just quick little things to get down for input today. In our input, we're going to start with just a few languages of the discipline. These are things you've probably heard before. You definitely should have heard them before because some of them came in the earlier lessons. The first one is absolute value. Absolute value. Now, can't even see that, I'm sorry. Absolute value is something you've worked with before last year as well. Absolute value should be something you're becoming pretty familiar with. And we were working on it a little bit earlier in these lessons too. An absolute value is just a number's distance from 0 along a number line. Just how far it is from 0. And a note to add with this one is that it is always non-negative. You will never have a negative absolute value. That's one of the reasons we use it so much, because it can never be negative. So, for example, and I'm sure you've seen this before, I'll write it down one more time. If we have 0 right here and 1, 2, 3, and there's 4 right here, and -4 right here, they are in opposite directions, but their absolute value is still 1, 2, 3, 4 units, and 1, 2, 3, 4 units. They have the exact same absolute value. The distance is the same. All right, our next term is additive inverses, another term we should know. Additive inverses. And an additive inverse is a number and its opposite. That's it, just the number and its opposite. Now, for me, the way I remember additive inverses is when I was a kid, I loved playing Zelda. Anyone's ever played Zelda? And in Zelda, in the Ocarina of Time, which was the first Zelda game I ever played, I remember playing and going into, and this is Zelda because this is Link because he's green. And I remember going into one of the little dungeon areas you have to go into, and I went in, and all of a sudden, I saw, and it was a terrifying moment, because you have your sword here. I saw an exact copy of me. The only difference was that he was wearing all black. It was like a shadow Link. And when he came out, he started to attack. I was very freaked out. I didn't know what I was supposed to do. So I swung my sword. And at the same time I swung my sword, he swung his. And it was the exact opposite, and nothing happened. Our swords just hit and bounced away. But I couldn't beat him because everything I did, he would do back. And it would just be nothing. So that's almost exactly what the additive inverses are. If you have a -14 and a 14, it comes out to 0. There is no change there. That's just the way I remember it. So there you go. And the last one is the inverse property of addition. Inverse property of addition. And what the inverse property of addition means is that you can switch the sign of anything you want to do. Let's say you are going through and you have a number, let's say 22 minus -30. Let's just say that. what you can do instead of doing this is anytime you see something like this, the inverse property of addition means that you can flip the sign and flip the sign of this. Use the opposite here and flip the sign. So instead of 22 minus negative 30, you can just say 22 plus 30. And make problems that were more difficult a little easier with the inverse property of addition. Okay, so that's all we're going to do right there. And we're going to go ahead and get right into some of the details I want to give us for today. So I'm going to go ahead and switch to a new piece of paper. And let's go ahead and draw our flower. That tells us we're going to be doing some details. Few things we're going to write down. Now, these are some rules too, so we may be using one of our other icons as well. But the first one I want us to write down is adding numbers with the same sign. With the same sign. So we're adding numbers with the same sign. We're going to go ahead, you can go ahead and also do this little rule icon over here because we're going to give some rules right here. Okay, so I'm going to give us 2 steps to follow. Step 1. Step 1 is to add the absolute values. So if you are adding 2 numbers and they have the same sign, either they're both positive or they're both negative, you can, step 1, add the absolute values. Step 2, you're going to give the sum the same sign as the addends. So if you are adding 2 positive numbers, your answer is going to be positive. If you are adding 2 negative numbers, your answer is going to be negative. So that's it. That's the easiest one, to add numbers with the same sign. So let's go ahead and move to the next one, which is going to be adding numbers with different signs. So we have the same sign, now we're going to have adding different signs. So again, we're going to have step 1. Step 1, you subtract the absolute values. So when it's the same sign you're adding, when it's the different sign you are subtracting. You're subtracting absolute values. Let's go to step 2. Just quick, easy steps on these. Step 2 is that the sum has the same sign as the larger absolute value. Sum has the same sign as the larger of the 2 absolute values. That'll be our second step there. And then that's it. Now the last one we're going to do is if you are subtracting any real numbers. Subtracting real numbers, there's a way we can do that too to make it less confusing. Step 1, when we're subtracting real numbers, is that instead of subtracting, add the opposite. Instead of subtracting, add the opposite. Step 2 is to follow the correct rule from above. So those might look like very simple steps and very simple rules, but it's good to have some of these simple things sometimes as we're going through. So when we're subtracting, now we're going to go through some examples where we can go through each of these. So I'm going to go ahead and write down that we're going into our modeling. And for some reason, let's go ahead and call the number we're about to do number 28. I don't know. Number 28. So number 28 on our modeling is going to be, we're going to be subtracting some fractions, or adding some fractions, sorry. Negative 2/3 plus negative 3/5. Okay. So now these rules are going to sort of come into handy for us right now. We are adding, right? We are adding. So we're adding, these are the two adding rules, and we're adding numbers with the same sign. So we're adding numbers with the same sign. So our step one is going to be adding the absolute values. Okay, so let's go down here and let's add the absolute values. First of all, one thing that we need to do, because these are fractions, is we can't add anything until we figure out what's going to make these have the same denominator. So 3 and 5, I know that 15 works there. So 3 times 5 and 2 times 5, and then 5 times 3 and 3 times 3. So really what we're getting now, this is going to equal negative 10/15 plus negative 9/15. Okay, now we can add the absolute values. So let's go ahead, we can put absolute value signs around those. And that's going to equal for us, remember, the distance, which really means just non-negative. So we're going to have 10/15 plus 9/15. And our answer is going to be 19/15. Which is not simplified at all. So 19/15 is going to turn into 15 goes into 19 one time. There's going to be 4 left over. 4/15. You can't simplify it anymore. Now we have to remember the last part of it. Give the sum the same sign as the addends. So you go down here, the addends both had a negative sign. So our answer to this is actually going to be negative 1 4/15. And that is going to be our answer. So that's number 28. Just for some reason we did number 28 there. All right, let's do another one. And for some reason, I'm going to go ahead and call this one number 35. And number 35 says -7 minus -5. -7 minus -5. Now this one's going to be a different rule, right? Subtracting real numbers. Instead of subtracting, let's add the opposite. Okay, well, let's go ahead and add the opposite. So now it's going to be -7 plus the opposite of -5, which we know the opposite of -5 would just be 5. Okay, now I know this is a very, very simple problem. You could solve this right now, but let's go ahead and do it through everything. So now we're going to follow the correct rule. The correct rule when you're adding opposite signs or different signs is that you're going to subtract the absolute value. So let's go ahead and subtract the absolute value. So this is now going to be the absolute value of -7 minus the absolute value of 5, which will give us 7 minus 5, which will give us 2. Now, we have to look in the second part that says the sum has the same sign as the larger absolute value. What was the larger absolute value? This had the larger absolute value because it became 7. So it's going to be negative. So our answer is going to be negative. Yes, that may be something you can do in your head or you can solve right here, but it's still good to know how to do it this way. Now let's get into something difficult. And not difficult, but different. So it's a long question because now we're using real world context here. I actually wrote it down already for us. And we're going to go back and we're going to solve that anticipatory set question, the American Ninja Warrior question. So let me read to you what this question says. To defeat the spider jump obstacle, competitors must jump from the launch pad to the entrance that is 9 feet above them. Then they must descend 3 feet to stay with the walls. Next, they must climb 11 feet and work their way to the dismount. To reach the dismount, they must descend 4 feet and then jump down 10 feet to the landing platform. What is the landing pad's vertical position from launch? Okay, so there's a lot of stuff in there, but now let's break it down, especially now that we know what we're looking for. So first of all, what do I know? I know that we're using the launch pad as 0. So I can just even write up there, launch pad's going to be 0. Then I know that 9 feet above them, right? That's the first thing. So that's going to be a positive value of 9. Then they must descend, which means negative 3 feet to stay with the walls. Next, they must climb. That's going to be positive 11 feet. Their way to the dismount. To reach the dismount, they must descend down 4 feet and then jump down, that's again negative 10 feet, to the landing platform. What is the landing pad's vertical position from the launch? Okay, so now we're trying to find how much that last thing is going to be. So let's go ahead and break this down piece by piece with all of the information that we now have. What we want to do is we want to go ahead and lay out all of our information into an equation, right? Into an expression of some kind. So let's start. What we're going to do is we're going to start with the fact that launch pad is 0. So we're going to start with 0. And we're going to add every time we go up. So 9 feet. And then the next one, we're going to subtract anytime we go down, minus 3 feet. And then we stay with next, they must climb, so that's going to be positive 11 feet. And then they're going to descend negative 4 feet, and then jump down, subtract 10 feet. So that's our expression that tells us what our answer is going to be. So let's go ahead and start to work through this. Now, this is not too difficult of a math problem, so you may just go ahead and be able to solve it. But I'm going to go through each step the way we go through, because as this stuff gets more complicated, we're going to want to know these steps. So first of all, we're going to subtract. We're going to use one of our techniques, which is to get rid of the subtraction. If we're subtracting, this is subtracting real numbers, we can change all these subtraction to addition. So let's go ahead and do that. So we have 0 plus 9. Now this is where the change comes in, plus negative 3. And then we're going to go back to our original, plus 11. And again, we can switch this now to plus negative 4 and plus negative 10. Now we have all addition there. Makes it a little easier. So one thing we can now do, and I'll use a different color for this, is we can go ahead and do the commutative property. The commutative property is one we went over a few lessons ago. And in the commutative property, we can adjust the way things are added, and it won't matter, right? We can group them differently. So let's group all the addition early and all the subtraction later. It's easier to take numbers when you make a subtraction problem at the end. So 0 plus 9 plus 11 plus, and let's go ahead and switch these around too and say negative 10 plus negative 4 plus negative 3. So now we have the positive numbers and the negative numbers sort of grouped together. And because we have the commutative property, we can also group things. So we're going to say end group. And I'm going to then group my positive numbers and group my negative numbers to make a simple equation. So I'm going to simplify this now. And let's go ahead and see right here. 0 plus 9 plus 11. That's going to give me 20. And we're adding 20 And if I look at all my stuff right here, I have -10 plus -4 plus -3. Those are going to get more and more negative. So I'm going to get, let's say, 10, 14, 17 plus -17. So now I have 20 plus -17. Now I can see that we have adding with different signs. Adding with different signs. And if we go back to our notes here, when we're adding with different signs, we're subtracting the absolute value. So let's go ahead and subtract our absolute value. We have the absolute value of 20 minus the absolute value of -17, which is going to give us 20 minus 17, the absolute values. Now this is a very, very simple equation. So let's just go ahead and say 20 minus 17 is going to be 3. And now we have to decide what was the highest valued absolute value. Well, it was this. 20 is higher than 17. So it's going to be a positive number, and it's going to be 3 feet above the launch pad. And that's going to be our answer to our anticipatory set problem for American Ninja Warrior. Oh, sorry. All right. So that's it that we have for today. We're going to have the guided and independent practice that we always have. So for guided practice, you are going to go ahead and go through your practice. So PSE stands for Practice and Problem Solving Exercises in the online book. And you're going to be doing number 19 through 45 odd. And remember, these questions can be, you do not need to print this out or anything. You can write that down on a piece of paper and you can keep it with your notes. This is your guided practice. You're going through and you're double checking that you understand how to do this. For our independent practice, which is that final check to make sure, it's that last thing we're doing, you're going to go and do the lesson 1-5 self-assessment. I'll give you a question based on each of the things we learned here, and you'll be able to see whether or not you feel comfortable with what we're doing today. Okay, that's everything for today. I hope everyone's having a wonderful day, and as always, go Buffs.